All right, folks, to save us some time on this next problem, I've already written down a few things. First, our given function is a rational function. If you type this in on your calculator, please make sure you enclose that denominator in parentheses. And we want to find f prime of 2, or the derivative at 2, or the slope of the tangent line at x equals 2. So I plugged that equation in on my calculator, and using the trace key, I found that the tangent point is 2, -1. Now, if we visualize drawing a tangent line through that point, so tangent to our function, what we can see is that the slope of it will be positive. So again, just kind of a good way to check yourself and visualize what it is we are trying to find graphically. Now, notice that I am kind of covering up this next little part. What I would like you to do is pause the video and see if you can write the limit definition for the derivative. So we've got f prime of 2. What comes next? So go ahead and pause and give it your best shot. So hopefully you got fairly close. It is the limit as h approaches 0. Again, a lot of times students want to put x, but the h is that distance between your hair beyond point and the tangent point. So we want to close in on the distance between those 2 points so that instead of needing 2 points to find the slope, we can find the slope at 1 point. So, f of x plus h, that's the y value of the hair beyond point, minus f of x, y value of your tangent point, and then the denominator is actually x plus h minus x, but the x's end up canceling, so it is just over h. So you can go ahead and just write this as your limit definition for the derivative. And again, I can't stress enough that this is work I'm going to be looking for on your homework. So next, it's just a matter of plugging in to that tangent point's x value in for the x part of our formula. So f of 2 plus h minus f of 2 all over h. Now, this problem starts getting really nasty because of the fraction involved. So we're going to take it kind of step by step from here on out. So first, when I plug 2 plus h in for x in my function, we get 1 over 1 minus, and we have to enclose that 2 plus h in parentheses because I'm plugging that entire thing in for that x value, and thus I'm subtracting both of those. So I'm going to make sure I put parentheses there. Then we've got our minus anchor, and now we want to find f of 2. So 1 over 1 minus 2. And this is all over h. So don't forget that h with every step of your work. All right, so in this next step, I'm just going to simplify the denominator of that first fraction by distributing that negative in. And that's going to give me 1 over 1 minus 2 minus h minus, let's see, 1 over -1 is -1, so minus a -1 is what we are left there, all over h. So this is my f of x plus h expression. This is f of x, or f of 2, and then there's our minus sign. Alrighty, so remember folks, anytime we drop down to a new line of work, we have to rewrite that limit notation. This limit as h approaches 0, this notation does not go away until we are able to use direct substitution and plug that 0 in for the h's in the expression, which we won't be able to do until we can cancel out that h on the bottom. So limit as h approaches 0, and then we have 1 over -1 minus h. So -1, or 1 minus 2 is -1 minus h. And then plus 1 all over h. Yeesh. So there's my first expression. There's my second. So we've got a kind of major problem here. First, this expression looks awful. Why does it look so awful? Because we've got a fraction stacked on another fraction. We've got double fractions going on here, which is no good. There's a few different ways you can simplify an expression like this. You can use the LCM or the LCD as a creative form of 1. I don't always love that method because students tend to kind of struggle conceptually what we're doing there. So I'm going to show you the method that I prefer, especially because this is something that will help us as we move into trig proofs. So up at the top, when you have two fractions on the top, we are going to start by adding them together. How do we add these two fractions together? Well, we're going to need to get common denominators. So good old common denoms. So we're going to try to add these two fractions on the top together first. So if you're like, well, is 1 a fraction? Yeah, we're going to just throw a 1 underneath of that and ta-da, now it's a fraction. So if we look at their denominators, this one, and I'm going to go ahead and trap it in parentheses since it's binomial, this one has a denominator of -1 minus h. This one has a denominator of 1. So how do we get these to have common denominators? We're going to use a creative form of 1 and multiply by -1 minus h over -1 minus h, so that this fraction will have the same denominator as that one. And again, as just kind of a quick review, let's say I had 1/4 plus 1/2. So if I wanted to add these two fractions together, we would need a common denominator. So to make this denominator look like that one, I would multiply by 2 over 2. That would give me 1/4 plus 2/4, and then I add the tops together to give me 3/4, where the common denominator stays the same. So again, I just like to show an easy example first so that this one looks a little less intimidating, because these fraction ones are really hard. And folks, please take your time with these on the homework. Keep those questions coming. You guys are doing so awesome so far, and these limit problems are a little bit tricky. So with practice, they will become much easier. So we look at our denominators, we multiply by a creative form of 1 so that this guy is going to have the same denominator. So our first fraction remains the same, 1 over -1 minus h, and then plus -1 minus h over -1 minus h. Pew, pew. Now, something to note about this plus sign. Sometimes students look at this. I'm going to go ahead and finish off. Dividing by h. Sometimes students look at this expression and they go, hey, I'm going to go ahead and cross off that -1 minus h with that other -1 minus h. Folks, can we actually do that? No, because it's not multiplication. You can't cross simplify across addition or subtraction. So addition or subtraction. You can't do it. So if you're like, well, then what are we supposed to do from here? We're going to do the same thing we did up with this easy problem. Once we have a common denominator, we are going to add the tops together. So add the tops and keep the denominator the same. So I'm going to go ahead and add the numerators together. So 1 plus -1 minus h. So 1 plus -1 minus h. And now it is all over that common denom. And woohoo! The 1 and the -1 cancel. But I mean, this expression still looks, it looks awful, let's be honest. And it looks awful because I still have a double fraction. So our first step was simplifying the binomial expression or the two-term expression on the top to be one fraction. But now our other big issue in this problem is we're going to need to get rid of the double fraction or the fraction on fraction. And how we get rid of that is change it to be multiplying by the reciprocal. So remember, to divide fractions, you multiply by the reciprocal. All right, folks, so this step is going to refer to this fraction bar. So currently I'm dividing by h. Well, h as a fraction is h over 1. So instead of dividing by h over 1, we're going to change that to be multiplying by the reciprocal of 1 over h. So this is no longer here. We're changing dividing by the fraction to be multiplying by the reciprocal. Just like if you wanted to divide by 1/2, you would really multiply by 2. So this is now gone, and my new expression is I'm multiplying by 1 over h. So let's go ahead and drop down to our next line, making sure we've still got the limit as h approaches 0 of negative h over negative 1 minus h times 1 over h. So now, instead of being a double fraction, we have two fractions being multiplied together horizontally. So what should we do next? This expression is fairly simplified. If you're wondering, well, should I distribute that h to the bottom? Remember that our whole goal is that we want to try to be able to do direct substitution. Can I currently plug in 0 for h? Well, on the top is fine. Right here is fine. But since I've got this h in the denominator, that is no good. So is there a way for me to cancel out that h? Yeah, we can cancel out that h with the 1 on the top. Why? Because you can cross simplify across multiplication. So now what I am left with, and don't forget that negative that's still out in front, is negative 1 over negative 1 minus h. Now if you're looking at this going, but there's an h still in the denominator. There is an h there, but can I do direct substitution? Are we going to end up dividing by 0 or something that is a restriction? No. So once I get rid of this scuzzy h, I can now do direct substitution. So remember, once you do direct substitution, no more limit. And I denote that by doing the equal sign with the arrow, saying, okay, that limit stuff is gone. And now I simply have negative 1 over negative 1 minus 0, which we are plugging in for h. So negative 1 divided by negative 1 is 1. What equals 1? F prime of 2 equals 1. And I wanted to make this orange. F prime of 2 equals 1. And what does this represent? The slope of the tangent line. Of the tangent line. At x equals 2 is 1. And again, folks, you don't have to write that on your homework. I just want you to have this in your notes so that you can study it and remember it and have your notes when you go on to take calculus next year, and you will be able to remember what our answer actually means.